Welcome back, everyone. Today we're going to do some refining. We're going to take this old quarter, which is silver, or 60% silver, 40% copper, and we're going to refine it down to 99.9% silver. So let's get a weight on it, see what we're starting with here. Looks like 6.28 grams. So that'll be our starting point. We'll see what we get out at the end. Now what we're going to need today is some nitric acid, a quarter, and a beaker, and a little bit of water. We'll put the quarter in the beaker. That was easy enough. And we're using 69% nitric acid today. That's the right stuff. We're going to put in 10 milliliters of water to start with. I think that's going to be probably enough for the whole experiment. And then we're going to add 3 milliliters of nitric acid. Make sure you wear protective gloves. I'll show you why later. And we should see immediately a reaction take place. If you put too much nitric in, you'll have a runaway reaction and it'll boil over. But you see the foam stirring up and the solution is turning color. It should turn a bluish green color. That would be the copper going into solution. Let's zoom in here and give you a view. And that's what we've got going right here. Got a nice bluish green color and some foam. So we're reacting. So we let the reaction run for probably about 10 minutes. Let's take a look at our quarter and see how it's faring here. Okay, let's see if we can get a focus. But the face of the quarter that was facing up, of course, it looks a little thin on definition as far as the character on the front. But the back, which was down on the glass, didn't have a lot of reaction going on with it. It's still well defined. But we'll put it back in the beaker and let it fizz away some more. Now to help drive this reaction forward, we're going to apply a little bit of heat. So we've got this unit placed in our fume hood with our burner and put a cover on it to keep the nitric acid in. Now this does put out nitric oxide, which is very poisonous. So you don't want to be inhaling this. It's that brown red fume coming off. You want to steer clear of that. And right now we're at about 103 degrees Fahrenheit. So we should be good. We'll let this cook away for a little bit and see what we get. It's been about another 10 minutes and the reaction is slowing down a little. So I'm going to add another 3 milliliters of nitric acid. Kick this thing in the guts and get it going. Now here we see the reaction picking up and it's starting to put out a lot of fume. So we know we're going in the right direction. Let's get in here and poke the bear. See what our quarter looks like now. Okay. Yeah, the detail on the front is washing out pretty well. It's losing a lot of thickness. So we'll put it back in and Let it cook up some more. Now that we have a vigorous reaction going on, it shouldn't take too long. And I've decided to put in another 3 milliliters of nitric acid. So that's a total of 9 milliliters of nitric acid. And we're really going to drive this reaction with the heat and the nitric acid. You can see it fizz up and really start putting out some fumes. Boil, baby, boil. If you look close, you can see the edge of the quarter bounce by every once in a while. So it's getting, it's kind of stirring itself. So we're just going to relax here for a moment and watch this reaction bubble away at 400% of its original speed, or 4 times speed. You notice that there's no large piece of metal bouncing around anymore, so the quarter is pretty much thoroughly dissolved, and the green color of the acid is an indication of the presence of copper in solution. There's about the last piece of silver that's in there. Got a couple of little strays bouncing around, and this chunk, which won't take long. Yeah, there it goes. We'll let it sit for a moment more and finish doing its thing. Now we're going to filter the solution and get out any solid contaminants, which kind of concerns me. There seems to be quite a bit of contamination in the bottom of the beaker. I'm pretty sure we dissolved all the silver. I don't know if maybe I cross-contaminated and got some something that contained chlorine in there and created silver chloride. But the silver should be in the solution, not in the filter. So I'm not quite sure what this is. Maybe we can get a sample of it and test it, but it could just be copper. So to test to see if I knocked all my silver out of solution as silver chloride, I'm going to take this sample and drip some hydrochloric acid into it. And if there is silver in this solution, it will precipitate as a white fluffy cloud. And there it is. So this solution does contain silver. So I wonder what that stuff in the bottom of the filter is. We'll have to see if we can figure that one out. Well, we took the rest of the solution and put a piece of copper in it, which will cause the silver in the solution to cement out onto the copper in that white fluffy powdery stuff, and then slough off and fall to the bottom of the beaker. It's kind of neat. From time to time we have to kind of swish the copper around and knock the silver off of it. There's some silver stuck in the crevices. But yeah, if you just let it plate up on it, it slows down the reaction and it'll take longer. And that's one thing I don't want to do, is waste your time. Okay, we're going to speed up this video. It's a bit more interesting when you can watch that white silver powder shed off in clumps like that. Ooh, yummy. Okay, remember that silver chloride we created in that test? Well, here it is. And we're going to use the lye and sugar method later to convert it from silver chloride to metallic silver. And in trying to scrape a sample of this material off the filter, it turns out that it's a very thin layer. I really couldn't get any off, so there's no tests that we can really do on that. And if you'll notice, I'm not wearing gloves. And this is what happens. Silver nitrate will stain your skin. You won't see it right away, and it'll just be light purple to start with, but in the sunlight it gets dark. And you too can look like you have leprosy. Apparently I touched my face. It's not that it's painful, it's just that you'll look hideous for a couple of weeks. So now that we've precipitated our silver out of solution with copper, we're going to decant off the copper nitrate solution into our waste beaker and then give it several washings of water. I'm using just room temperature distilled water, which is about 80-90 degrees. But warm water at maybe 100-120 degrees would be best. The idea is to keep rinsing and pouring off the rinse water until the water pours off clear, or as near clear as you can tolerate rinsing. And here you can see I'm rinsing our silver chloride solution as well as our precipitated silver. Just saving some time and doing them both at once. Now we're going to convert our silver chloride back into metallic silver using household lye and some sugar. So what we want to do first is take our material and see if we can get it focused. We don't have a lot, but it's a good test. See, it's kind of a whitish, maybe a bluish color sitting in the bottom of the beaker. And we want to add in a little bit of lye until when we pull this spoon up the side of the beaker, it all shows black. It doesn't show any more light color, because once you add the lye, it will start reacting with the silver chloride and it'll turn black. Now once that reaction is complete, your solution should be a dark color. The material on the bottom should be almost black. And the next step is to add a little bit of sugar. Now you won't see a lot of foaming as far as a reaction goes, but there is something going on there. You're converting the silver to metallic silver. It's a silver oxide right now. But once you're done, you should have material in the bottom that is a little bit lighter than it was before. It's kind of hard to judge, but if you try this method, you'll get the hang of it fairly quick. And we're going to decant off the liquid and give it a couple of rinses. Rinse and repeat till you get a clear water. In the bottom of that beaker is a metallic silver. It doesn't look shiny because the particles are so small. Now if I was doing this on a larger scale, you would actually see silver plating out onto the sides of the beaker, giving it a mirrored effect, which is kind of a cool effect. But in this case, we're working with such a small amount, we don't get that. We don't get that option. This stuff's a little lumpy, so you got to stir it. And that's about as far as I'm going to go in cleaning it. The water is kind of clear, but yeah, close enough. Now here's our silver from our silver nitrate precipitated with copper. We're going to pour the water off that. That's pretty clear water. And then we're just going to add the two samples together, because at this point they're both metallic silver. They're just in different sized particles, so they reflect light a little bit differently. So there's our silver in the bottom. It's a lot bigger than a quarter, but that's just because it's a fluffy powdered silver. Here we're mixing both silvers together. Got a light colored silver and a dark colored silver, but neither one of them are colored silver. Kind of weird, but that's chemistry for you. So we're going to add these two together, let them settle out, and then pour off the liquid, and then set it aside to dry. And there's our recovered, hopefully high quality silver. At least it doesn't have the copper in it anymore. Now we've got our oven out. Gonna set it up so it's ready to go. Once you get this thing heated up, you don't want to be reaching in there. It gets real hot. So set everything up before you turn it on. I'm using a coupelle today instead of a melt dish. A coupelle has the benefit of taking out some impurities. It gets absorbed into the bone ash. I should have preheated the coupelle before I used it. You'll see later on it starts to deteriorate as I pour the silver out of it. And I think it's because I did not preheat it. So we'll set this thing to about 1960 degrees, which is a little bit above melting temperature for silver. And we'll put our silver powders into the coupelle. And I thought I had it pretty dried, but it's kind of like mud now. Wants to stick to everything. Well, I managed to get most of it into the coupelle. And next we added some borax on top. This helps keep the silver from oxidizing while you're heating it up, so you won't lose as much silver, or you won't get a oxidized layer on top of it. I should be using anhydrous borax, but I'm cheap. I use regular borax, which has some water in it. And then we put it into the oven to cook. So after about 10 minutes I got curious and opened the oven, and it's hot as hell in there, but the silver hasn't started melting yet. So we'll close it up and let it continue on its way. Ow. Ooh, that shit's hot. Ouch. Dumbass. Okay, for our mold today, we're just going to use a conical mold. I know we're not going to have enough to make a small ingot, so conical mold will do. Now the thing about molds, either cast iron or graphite, you want to preheat them and drive off any water that might be in the pores. If not, when you pour molten metal into it, you'll have a small steam explosion and it'll blast metal all over the place. So just take your torch and heat it up. This process also reduces thermal stress, so when you pour molten metal into an item, you don't cause it to crack. You don't have to get it glowing red, but you do need to warm it up so it's impossible to touch by hand. You are pouring 1900 degree liquid metal in, sometimes hotter if it's a different metal. Okay, let's take a look at our silver here and see where it's at. Oh yeah, it's nice and molten. Kind of clean and shiny on top. That's what we want to see. So let's get pouring. See, here's where the crucible starts deteriorating. And I got some of the silver stuck in the bottom, but most of it made it into the mold. I'll pick out the silver that's stuck in the bottom and set it aside. I'll include that with that silver button that we just poured, and that will be used in the future for separating silver and gold in a process known as inquartation. Well, let's dump our silver out and see what we got. There's our silver. We pick this up, and I got a beaker over here with water to cool it down in. Let's move the camera around. I think it's probably cooled down enough that we aren't going to see any sizzle. Yeah. Well, now just take a pair of tweezers and pick it out. And there's our silver. That should be 99.9% pure silver, or thereabouts. Sure looks nice. Let's weigh it up and see what we get. It's 3.61. So we lost about 50% of our mass. 40% of that should have been copper. So yeah, we're pretty close. I know I did lose some because my processes were kind of screwed up, and I'm wearing some of it now. This is what I'm doing this for. Well, not for nickels. These are silver nickels. I might get around to doing these. Those are only 40% silver, 60% copper. But what the hell? Anyhow, hope that helps you out. See ya. But whatever.